All right, today we are through with any of you getting cooked because we're just going to go ahead. I don't know if I use that right. We're going to go ahead and just use a quadratic formula, right? Okay, so we left off here and let's dig in. I saw a lot of really good stuff happening. If you made a little mistake, I want you to be very mindful of it because I want you to tell us what the mistake was. Cool. All right, as we go through, the very first thing, what does this clean up to inside of my square root? What we call the argument of a square root, or more formally, the radicand. 4 minus negative 48 is what this shakes out to be. 4 minus a negative 48. And when we have a minus a negative 48, they turn to a plus. I'm skipping a little bit of work just in the interest of time. This should be a square root of 52. Okay, if it's not, what did you get? I heard oops. Okay. All over what? Negative 6. 2 times negative 3. That's 2a in our quadratic formula. Okay, now clean it up. Instead of doing it inside the radical, I'm going to do a little bit of scratch work off on the side. If I think about 52, is there a nicer way to write 52 for simplifying a radical expression? 4 times 13. Why would I want to write 52 as 4 times 13 instead? Yeah, I know the square root of 4. That's pretty handy. So here we go. Negative 2 plus or minus. What thing comes out of here? 2. So I'll cross that out. It's kind of like scratch work on the side. 2 times the square root of 13 over negative 6. If you have gotten to this point, you have the right answer so far. It's not completely simplified, but that's like the very last little part of the problem. Is there anything that goes into both the numerator and the denominator here? So I don't care if it's 2 or negative 2. I actually like the negative 2, Angel. And there's a weird little thing that happens here. If I do a negative 2 and I factor it out, what stays here? A 1. And then here's the really weird idea. This was plus or minus. If I factor out a negative 2, does that change? It doesn't have to. Now, if you want to be really specific, I guess it does. You could rewrite minus or plus, and sometimes you will do that. But realistically, one of them is still going to be positive and one of them is going to be negative. I can just keep it plus or minus. I have no issue with that. That is the weirdest thing that we have to do. I have factored out the 2. I just didn't write this 1 that would be left behind. Now, why would I factor negative 2 out of the numerator? Like, what was the benefit of doing that? Hey, what's the bottom? Does it have a negative 2 in it? Times 3. And now I see in this problem, I just naturally get a negative 2 over negative 2. And what's anything divided by itself? Boom. Check it out. Our final solution, our roots, our x-intercepts happen at 1 plus or minus the square root of 13 over 3. Is my answer right now exact or approximate? It is exact. Now, if you were to actually try to graph this function, is this super helpful? No. Somebody with calculators handy, will you let me know what 1 plus root 13 over 3 is and 1 minus root 13 over 3? And I'm going to go ahead and graph this function here. So I'm going to have to scroll up so I can see it. Negative 3x squared. Negative 3x squared plus 2x plus 9 or 4? I'll just scroll up. 4. I have a sneaking suspicion that your numbers are likely to be 1.53518, and the other one is probably negative 0.86852. I can see these numbers showing up. If you got something different and on your calculator, my guess is that when you type it in, you might not have used parentheses around the entire numerator. If you don't, when you type divide by 3, it's only the 3 that gets divided. Yes, sir. This one right here, because you probably have a 2, right? Okay, all we've done is saw that this term and this term both had a 2, so we factored it out. So if you factored a negative 2 or divided this by negative 2, it's just a 1, right? Okay, cool. All right, quadratic formula, super useful for us, like incredibly helpful. Do we need to complete squares anymore to solve equations that can't be factored? No. Can you still if you want to? For sure, but why would you if we've already completed the most general square there is to derive the quadratic formula? Sebastian. So we only factored out the pieces, and kind of, yes, to be honest, you can just pick what you want to factor out as long as it goes into both of them. So on this one, notice they both had a 2, right? 6 and 2, they both have a 2 in them, so we factored out a 2. We're essentially just taking out the greatest common factor of that numerator. Say that again? Like if it was just like this? You couldn't, because everything gets divided by 4. What this is really representing, and we don't typically write them this way, but I can split this fraction if I want to. I could do this, and I see the same thing. I could split it up here and then simplify it. That works just fine. We don't normally do that, though, but they're the same thing, yes. All right. Quadratic formula seems okay, seems awful. Can you guys give me some sort of gauge? Thumbs up, thumbs down. Okay, it takes practice. I'm going to be honest, I don't love it. Like, it's nice to have, and it's a super valuable tool that we will certainly use sometimes, but I still want to make sure, and I would encourage, you should continue to factor everything that you can without the quadratic formula, because it's so much nicer. Okay, little tiny bit of stuff here today. Little tiny bit. Okay, when we talk about the roots of a quadratic, on the graph, what do they represent? The x what? Intercepts. Okay, now, here's my challenge for you. I want to think about the solutions to quadratics. Solutions. And I could have written 3 other words here. What are they? Zeros, roots, not x-axis, but you're close. X-intercepts. Okay, we're going to take a quicker look at the solutions of quadratics. This chapter is fairly unique in here for one particular reason. Every other chapter that we see that we'll go through, we don't use i's anymore. Like, we only use the complex numbers when we're talking about these, just so that you can get a little bit of exposure to them. The imaginary values, they don't show up on our graphs, and there's a reason for that. It's because we don't graph the imaginary axis with these. Now, for these, I'm going to make a claim. A quadratic, which is just something with what power of x as its biggest? Square. Okay, a quadratic can have blank, blank, or blank x-intercepts. Now, these are going to be numbers here in a second. If we imagine a quadratic, any parabola that we're just thinking about on a graph, or if you can't imagine it in your head, if you want to try to sketch it, can you sketch me a quadratic that has one solution, one x-intercept, one root? Sketch really simple. I don't need like axes and I don't need numbers, but let's just check. You say you can do it with 1. So here's all I need. Can you sketch a quadratic on this coordinate plane that has one solution? Okay, yep. Go ahead and do so. If you can do 1, that's cool. Can you do 2? Can you do 3? Can you do 4? What are the possible values that we could have for the number of roots that could show up? I'm going to pause this. So if that question seems kind of odd, because based on your facial expressions, it might be, I'm going to claim that I think it can probably have one x-intercept. Does that graph exist? Is it this? No. Why? Oh, it's this, right? It's something like this that touches the x-axis here. Does it have to go up like this? No, I could draw another one if I wanted. I'll just do it dashed. Does this quadratic right here also have one x-intercept? Yeah, so 1 is possible. Can you do the same thing with 2? Okay, that one's pretty quick and easy to draw. Could you do it with 3? Do it. Draw me a quadratic, a parabola, yes, that has 3 roots. No, it has to be just this. See yours? Ooh, Michael says he thinks it's 1, 2, or none. I don't think I can do 3. I'm pretty sure I can't, right? Okay, if I want to have 2 x-intercepts, that's pretty doable. What do I do with this quadratic right here if I wanted to have 2? Can I just move it down? If I move it down just a little bit, does that have 2? Hey, look, there they are. Awesome. Okay, I can't do 3 though. Can't do it because we would have to have more turns in it, right? Can't do that. That's just this U shape. What's the other possibility? How do we draw a quadratic that has 0 x-intercepts? So it's either smiling, right? And are you guys okay? Smile and frown. Okay, it's either smiling and its vertex is above the x-axis. So this guy doesn't have any x-intercepts, or this guy doesn't have any x-intercepts. Now, in these 3 situations, if you are trying to solve a quadratic and you're looking for solutions, it's beneficial to have at least an idea of what's going to shake out here. Because why would I spend time trying to find a bunch of x-intercepts if there aren't going to be any? So the question becomes, how do we determine whether or not this graph, or any graph rather, would cross the x-axis? And there's a really, really easy way to do this. In the quadratic formula, which part of it would spit out i's in the end? The square root part of it, right? Like that's the only way that we get I, because I is defined to be the square root of what? -1. So with this idea in mind, we have a new lovely vocab to sneak in here. We're going to talk about briefly the discriminant. Discriminant. Cool. Not to discriminate, but discriminant. Okay, the discriminant. It is a very specific, like obviously math vocab, but as we look at this, there's a really easy way to define it. First and foremost, we'll just do the like pure words. We're going to say the square root, and I don't know why I wrote that, the square root part of the quadratic formula. And I'm going to go ahead, since this chapter or this section has been all about quadratic formulas, is it reasonable to say quad formula for that? If you want to write the word quadratic instead, you can. Quad formula is just our shorthand, not very short, for quadratic. Okay, the square root part of the quadratic formula. Now, if you look down at your page, very specifically, what are we taking the square root of? Like on the quadratic formula, what goes inside the square root? Negative b plus or minus the square root of b squared minus 4ac. This right here is the discriminant, the b squared minus 4ac. Now, when we calculate this out, there are really only 3 possibilities. And I just want to connect here. Notice there were 3 possibilities for the types and roots that we might have on any quadratic graph. For this, just to be really clear and language-wise, the square root part of the quadratic formula, what do we call the stuff that we're taking the square root of? Like the stuff that we're dividing, like if I had 10 divided by 2, the 10, the thing that's getting divided, is the dividend, is how we call that. What's the thing that we're taking the radical of? That's right. It's the radicand. Just like the dividend is what gets divided, the radicand is what is in the radical. Okay. I'm okay with the stuff in the square root. Radicand is the real word. Okay. So check this out. I'm going to make the claim. There's only 3 possibilities for what number this gives us. 3 possibilities. And again, just to reconnect, maybe they connect exactly with these 3 different types of possibilities that we have above on our graphs. Okay, whatever these numbers are, A, B, and C, one of these possibilities, and these are in no particular order, so one of these possibilities is that b squared minus 4ac is a positive number. Okay, if we had a positive number, something greater than 0, like, I don't know, 5, I would then have some number plus or minus 5 over, I'm just going to say 2 for now. Like, it's weird without it. I'm going to actually write it up here just so we can see one. This, if you want it, you can, but this is in pink, is just for think, okay? So check it out. If I had the quadratic formula that gave me 2 plus or minus the square root of a positive number, 9, over, let's say it's 6. I'll say 7 for some reason. How many roots does this give me? You say 1, I disagree. Now, as we look at it, and I can even make this nicer, and we'll come back to it. What's the square root of 9? So if I were to get to this point in my quadratic formula, one of them is 2 plus 3, which is 5 over 5, is 1. I have 1 from 2 plus the square root of 9, and I get a completely different number when I do 2 minus 3 over 5, right? I just got how many numbers? Why 3? So if you're saying 3, my guess is you're looking at these 3. But let me rephrase this. If we solve this and we work it all the way down, and I'm just going to say that this square root of 9 is 3, right? What's 2 plus 3? Over 5 is 1. And what's 2 minus 3? I think it's negative 1 over 5. How many roots did we find? 2. So, okay, that's fair. Now, check it out. What we have just kind of reasoned out, and we've only shown it by one example, but we could do it for infinitely many more, is if my discriminant, b squared minus 4ac, is greater than 0, how many zeros or roots or x-intercepts or solutions are we going to find? 2. Now, they're going to be very specific. They're going to be 2 real roots, which means we get to actually see this graph cross the x-axis. They're the real numbers. That's what's on our coordinate plane. We can see it. Alternatively, here's only one possibility, and I'm just going to switch colors so they stand out from each other. Is there any other possibility for what b squared minus 4ac could be equal to or inequality with? It could be positive. Give me another option. Could be negative. I'm cool with that. And I want to see, what does this imply? So we'll go back over here. I'm just going to do some more scratch work in pink, and let's work out a nice number. So let's say, I don't know, give me a nice negative square. Negative 9 works for me. Over 2. And I'm just plugging in. There's no real equation that these are coming from. I'm just saying maybe the quadratic formula gives us something like this. If these are my roots, help me find them real quick. Help me simplify. This is 1 plus or minus. Square root of negative 9. I, and then square root of 9. 3. I think this is 3i. Over 2. Now, in this case, do I still get 2 answers for x? I get 1 plus root or 3i over 2, and I get 1 minus 3i over 2. These are fundamentally different than these, though. These ones I get to actually see cross the x-axis. For these roots, we say there's no solutions, right? No x-intercepts, and that's still true. It's because our roots weren't real numbers. They were what? So they had an imaginary part. I'm cool with that. We're going to say that in this situation, we get 2, and I'm going to say imaginary. I'm fine with that. Or better language that I should have just committed to, let's say 2 non-real roots. Now, imaginary is fine here, just so you know, but I'm going to make one follow-up comment with this. Doesn't cross x-axis. Now, there is a little bit of weirdness in this statement because it does actually cross the x-axis. We just don't see that extra dimension because it's the imaginary dimension. Our graphs, this example here, it doesn't have any x-intercepts that we see because they're not real. This is our 2 imaginary root solution. Like, no real solutions, but there's 2 roots still. They just happen to have an I in them. Okay, there's one more possibility that we have. The discriminant could be positive, which is nice, 2 real roots. Ooh, equal to. I want you guys, using a little bit of scratch work on the side of your page, I want you to do the same thing. Make up your own end of a quadratic formula, but instead of negative 9, what are we going to put in there? 0. I want you guys to, and I guess we can just use the same one. That works fine and dandy. How many solutions does this spit out? You say none. Be careful. What's square root of 0? So 0. What's 1 plus 0? Over 2. So 1/2, I get it. What about 1 minus 0? Are you sure? 1 minus 0 is still 1, right? Over 2? So we got 1/2 both times, right? So here's the weird little part that we have to deal with. For this one, in this situation, if we get exactly 0 for our discriminant, this is the handy case. It's our perfect quadrat. I don't know how to disregard that. If we get exactly 0, then we imply that there is one real x-intercept, and I notice that I changed the language, x-intercept. However, when we say this, like one real intercept, I'm fine with that. That's what we see on the graph in our first possibility, right? One answer to this. There is a little caveat here that I want to make as well. In this one, if we went all the way through and I solved it, and it's going to look silly, but when I do the positive one and the negative one, I get 2 answers still. They just happen to be the same, right? Like 1 plus 0 and 1 minus 0. They give me the same number each time. When we do that, it's super strange. We only see one x-intercept, but there are still 2 zeros or roots, but it repeats. Now, this situation is like our perfect square trinomial. I can have the one solution to my equation show up, but it showed up 2 times. Notice, in each of these 3 situations, if we just say the roots or the zeros, this one has 2 roots, this one has 2 roots, and this one has 2 roots. It only has one x-intercept when we graph it, but they all have 2 roots. And I just want to real quickly check, what's the power of a quadratic? Square, and square is a what number? A 2. Weird that those are the same. Or not, I don't know. Okay, as we deal with this, what we can then use this for is a better way to get a good feel for what an equation might look like or solutions, and it serves as a nice convenient check to see, well, do I know what this is going to produce? So one last example. Here we go. And this is going to be kind of a tricky one, but I love it. For this, I want us, for the following, to find a value or a b value such that the equation, or the quadratic rather, the quadratic has, let's say, 2 real roots. Okay. Now, there are going to be a lot of b values, and we're really going to find a range of them, but if all we're asking for is one single answer, we get to pick. And here is our lovely equation. 5x squared plus bx plus 5 equals 0. Okay. This thing is very different. We don't have that number b in front of us, which means I can't even try to do any factoring, right? Like, I don't know what this number is, can't do it. Bummer. If only we had a way to kind of get a good feel for what type of roots might spit out of a quadratic with, I don't know, maybe the discriminant somehow. If I want 2 real roots, what's the discriminant, first of all? And what is it exactly? So what I know, just based on this statement right here, if I need 2 real roots, and I'm going to scroll down so that you can't just look at mine, I know for a fact then that b squared minus 4ac has to have some relationship with 0. Is it equal to, less than, or greater than? If we have 2 real roots, what's my discriminant? Okay, Angel said greater. If you're not sure how he came to that, what I want you to do is look at your notes, turn and talk with your neighbor for like 30 seconds. How did Angel know that this has to be, you said greater than 0? I agree with you. How does Angel know this? Yeah, and it's a pretty quick and easy question, as long as you're looking down at your notes. What do you think? He's right. Okay, do you agree? I'm fine with that. Okay. Oh, sorry. How do we know it's greater than 0? Yeah, it's right written right there, right? Like, it's a kind of a weird question when we say it, but cool. All right, so here we are. That was a really strange question, kind of, because it literally just required, instead of you guys giving me blank faces and eye contact here, you just had to look down, and I assume, and I think everybody immediately saw that when you look down at your notes. Okay, which means I know that this has to be greater than 0. Do we know any of these values, A or B or C? I know A and I know C. So let's just plug in what we know. And I'll go ahead and make that comment. Plug in. And I'm going to be more specific here than you would ever need to be. But what is A in this problem? 5. And what's C? 5. So let's just see where this takes us. We get B squared minus 4 times A is 5 and C is 5 equals 0. And I'm going to just do little steps along the way. I want to clean this up. B squared minus what number? 100. Somebody second that? 4 times 5 is 20 times 5 is 100. I agree with that. Is greater than 0. And we're almost there. And we're going to check an Algebra 1 idea here right away. If I want to solve this inequality, what would you have me do? So before I take the square root of 100, because I don't want to take the square root yet, I'm going to add 100 to both sides of the inequality. And I'll go ahead and add that in. So this just turns into 100. And then I just add 100 to each side. And then here's the Algebra 2 question. How do I do this? I'm going to take the square root and something wonky happens. Now, there's a couple different ways that we can think about this. I'm not sure if you guys did this in Algebra 1, and even if you did, it's been a couple years for most of you guys. I'll take the square root. I'm fine with that. Am I only going to get one inequality, or do I get 2 out of it? I get 2 out of it. So help me out here. I'm going to take the square root here and plus or minus the square root here. What do you want me to write? And how did you write it in Algebra 1, if you recall? So B is greater than 10 and 10 and negative 10. How do I write it? Positive and negative. So I'm a weird idea there, because check this out. I think that there's a lot of overlap in that one, isn't there? And it's okay, like if you're writing this, naturally that's okay. We may cross this out here in just a second. Like, don't stress about it. Because there's something weird. Give me a number B that if I squared it, it's bigger than 100. 11 works. Give me another one. 12. So you can keep getting bigger, right? Go to the other side of 0. Negative 1 doesn't do it, because negative 1 squared is only 1. That is not greater than 100. Negative 11 now will do it. So what we see is on the outsides of those, right? So we need a way to sort that out. The way that I did this, and I'm just going to cross this out because I like it a nicer way. I'm about to tell you the dumbest sounding thing ever, but it's worked for years for me to remember. Is this more or less? B, and I know that's not the real language that we use, but B is more than 100 or more? Okay, this dumb device, and I realize that there's some issues with it, but in my head when I see this, if I have an ugly inequality with the square stuff, I'm going to say more or, which is super strange to deal with this. Now, when we deal with this expression, more or, it tells me that I'm going to have it's this range of values or it's this range of values, because we don't want all that stuff in the middle. When we break this thing apart then, I break this into 2 situations. The first, like you guys told me, the positive, it's nice. But I don't want this plus or minus here. We're going to say that it's B is greater than the positive, or B is less than the negative version of that. Now, there's a few different ways that you could approach this. Instead, it would be wonky to do, but I could write the plus or minus on this side and get the same outcome. And it would be a little bit more clear because we would divide by a negative and my inequality would switch. If you are cool with more or, then I'm fine if we just split it up into or here. Okay, now looking at this, this gives me a whole infinite range of numbers. What is all the numbers greater than 10? Like you guys have already told me a bunch of them, right? 10 is not, but 11, 12, 13, 14, 15, so forth. Negative 11, negative 12, negative 13, so forth and so on forever and ever. Which means in this problem, if we were just said find a B value, can you give me a single B value? 16. Check it out. That works. B equals 16 works. Give me another one. 17. I'm not going to write infinite numbers here, but there's like a ton of choices, right? If the question is just give me a b value, pick one of them. I'm fine with it. B equals 16 works just fine. If it said give me a range of values, can you tell me the range of b values at work? So that's not quite a range, an interval, if you will. There's a faster way to say that. Instead of saying 11, 12, 13, 14, 15, 16, 17, that's just b is greater than 10. All real numbers doesn't work here. How come? Yeah, there's a lot of numbers that are not greater than 10 or less than negative 10 at the same time. Anything between negative 10 and 10 would fail. Okay, so with this, I'm okay with calling it here. I want you guys to have a little bit of time in class so that if there's questions, and that is homework, obviously, but let's knock it out. So here we go. 1023. This was 2.6.3, and I'm not going to name it here. But for this evening, I want you guys to work through homework 2.6, and you will find this waiting for you on page 103. You get problems 9, 11, 17 through 29 odd, 32, and 36. Okay, I do not have study hall today, but even if I don't have study hall, I'm usually here till like 4. So if you need a quiet place to come and ask some questions or to work, you're welcome to come in here for a little while after school. Let's commit to the next 10 minutes, get a head start on it. At the start of class tomorrow, I was going to do it today, we're going to shake stuff up. If you are sitting at the very front because of vision, you can stay where you are. If you are not in the front row because of vision, tomorrow you're going to sit in a wildly different location. Don't just switch one chair over. We're going to completely switch up the classroom. Sweet. All right. I'll have you guys do it to it then.